Hello and welcome to today's demonstration of Bradley Navigator high-low thermostatic mixing valves and Bradley's emergency thermostatic mixing valves. Behind me I have some equipment that will allow me to demonstrate how these valves perform in various situations. Instrumentation will collect data on flow rate, on pressure and temperature, and display that information on the monitors so we can see how the valve performs under various situations. So I'm going to go ahead and begin a test here. My first test is going to be with a Navigator high-low 45. Start the flow of water and begin a test. The instrumentation is collecting the data and displaying it on the screen here. If you look, we have temperature, pressure, and flow rate. Red indicates hot water temperature, green indicates cold water, or mixed water temperature, blue indicates cold water temperature. Same with pressure, blue is your cold and red is your hot, and my flow rate is down there at the bottom as yellow. That same information is also displayed on this screen right here. So we're flowing steady at 22 degrees at a very steady temperature, as you can see, going across the top there. This is a high demand situation if we're looking at 22 gallons a minute, but how well does the valve respond to low demand? I'll reduce the flow down to a gallon or two a minute, and you can see that my temperature is still held steady across the top. Another common situation that a valve might be subjected to is a change in pressure. Right now we're running about a little over 30 pounds of pressure on the hot and the cold. I can artificially adjust right here to simulate a drop in cold pressure. I will take the pressure down by about half. But again, notice my temperature still remains constant across the top. Now what about the catastrophic events that might occur? What happens if the valve were to lose hot or cold water at any time? If the valve loses the hot water, the thermostat responds by shutting off the flow from the mixing valve, almost down to nothing, within a half a gallon or less. Once I reintroduce the hot water into the valve, within a matter of seconds, I will come back to the desired set point. Now, if the reverse were to happen, if I were to lose the cold water for any reason, the thermostat heats up and drives the piston down into a safety shutoff, eliminating the flow of water. When I introduce the cold water back, I'll get a sudden rise in temperature, sudden drop in temperature, but quickly flattens out to the desired set point. Well, that is how the high-low 45 valve responds in various situations. Let's change this up to an emergency mixing valve and see how it responds. I've removed the center section from the high-low valve, and I'm now inserting the center section to the emergency mixing valve. Pipe wrench, socket wrench, any common tool can be used to replace the center section. You also know we use the same valve body for an emergency mixing valve as we do a high-low mixing valve. So that if you ever were in a situation where a high-low valve was put in by accident with a drench shower, you could simply remove the center section to make it an emergency mixing valve rather than changing out the entire valve body. So now we've turned this into an emergency mixing valve. I'm going to repressurize. And I will begin another test. Start the flow of water and let the instrumentation collect the data. You notice my mix temperature is lower in this case. Because I'm using an emergency mixing valve, we want a temperature that's lower than 90, 95 degrees. So this is set at about 85. This would be a typical flow rate if a drench shower or something like that was being used, but what if it were just an eye wash? And reduce it down to the flow about what an eye wash would do, and you can see we're still really holding temperature within a couple of degrees of that 85. But now what happens in an emergency valve if the hot or the cold are lost? This is really where it differs from a high-low thermostatic mixing valve. If the hot water is lost for any reason, we have an immediate supply of cold water still available. This is through fixed cold water bypass built into the valve. We don't regulate how much cold water flows through the valve. We simply regulate how much hot we add to the cold. And by doing so, we don't have any mechanism that has to move to allow full cold flow. So no matter what the situation, you know you're going to at least get cold water through the Bradley thermostatic mixing valve. If the cold water is lost, the valve will sense this, the thermostat will expand and shut down the flow of water. As you can see, we've shut off the flow of water on our instrumentations here, and now we're just emptying out what's left over in the pipe. Once I allow the hot, cold water to flow back through the valve equally, we'll quickly return back to our desired set temperature. To change temperature in a mixing valve is very easy, just with a common tool. Through the top, 5/16" Allen wrench. If I turn in a clockwise direction, I will get a cooler setting. If I turn in a counterclockwise direction, I will increase the temperature. That concludes today's demonstration on Bradley Navigator high-low thermostatic mixing valves. For more information, please visit our website at www.bradleycorp.com. Thank you.